Hello, everyone. My name is Ramu, and I'm here with my colleagues Rahul and Melly. We're from the Oracle Spatial and Graph Product Management team, and we're excited to talk to you today about tackling complex problems using graphs, a feature of Oracle database.
And the best part is we'll be using SQL, a query language many developers are familiar with and many tools understand.
That's definitely the best part. SQL Property Graphs allow you to query data as a graph, simplifying complex joins and making relationships more intuitive. As Ramu said, I'm a product manager for Spatial and Graph, and I've been with the team for 3 years, and I'm in Denver, Colorado.
And I've also been with the team around 3 years, located in Miami, Florida.
And I've been with the team a little longer, for around 25 years, and I'm based in Nashville, New Hampshire. Rahul and Ravu will be showing you a demo, and I will then be walking you through what's happening under the hood.
Today, we will talk about O Auto Parts, a fictitious manufacturing company that uses graphs to tackle components across different car parts, manage requirements, and map dependencies between components.
With graphs, they can plan their production efficiently and optimize their supply chain process. They can map component dependencies, anticipate shortages, or avoid bottlenecks by ensuring orders are placed at the right time.
And graphs are all about relationships. They can help to reduce errors by providing a clear understanding of component dependencies and minimizing costly production mistakes caused by incompatible parts. Let's represent this as a graph.
This will look like a hierarchical graph where we start with O auto. An auto needs multiple components to be built, such as heating, ventilation, air conditioning, transmission, body and interior, electrical, engine, etc.
And some components are made up of even smaller ones. Take the electrical system, for example. You've got the alternator, headlights, battery, and each of those has its own parts too. What we're really trying to figure out is, are there dependencies between them? And are some components part of multiple dependencies? That's where graphs come in handy.
Exactly. With graphs, we can easily see how something like a wire is not just a single component, but a crucial part needed to build the alternator, headlights, a battery, and the car's electrical system. Let's take a look at a demo to see graphs in action.
In this demo, we will show you how an automotive company can use graphs to explore product relationships, track inventory, prioritize customer issues, and streamline supplier management using Graph Studio. Let's get started. To begin, I'll sign into Graph Studio, then click on the graph icon. This brings me to the page where I can create my graph. I'll click on Create Graph. I'm prompted to name my graph. I'll go with Auto Graph. Once that's set, I'll click Next to continue. Now I need to select the tables for the graph. I'll be using 5 different tables: customer tickets, supplier, category, product, and component. With these selected, I'm ready to move on to the next step. The tables are automatically categorized into vertices and edges based on their primary and foreign key constraints. This helps define the relationships in my graph right from the start. I'll select Next and then Create Graph to finalize the setup. Once my graph is ready, I'll move on to querying it in the Notebook menu. Now that I've created the graph, I'll hand it over to Rahul to query the notebook.
I already have a notebook called Automotive Orders, so I'm ready to start querying my graph. I'll run a query to see how the graph looks. Here I can see how customer tickets, products, categories, and components are connected. I get a high number of sales for electrical components. This graph shows us all categories and products under the electrical systems categories that we sell. I can also go to Settings, change the layout, and add a highlight to show the products that are out of stock. This helps me prioritize orders for these items. One thing I'm interested in is the number of tickets or issues filed by a customer. By running this query, I quickly see that the bearing for the high-performance gasket is at the top of the list for the most reported issues. I'll take a look at the product ID number 59. Looking at the visualization, it has 2 different bearing components. I can also view this information in a table by switching to Table View. Now it's time to contact the suppliers for these components to order replacements and check if they're experiencing issues with these bearings. This query gathers the information on who supplies these components I can easily see the supplier for these components, helping me take the next steps in ordering replacements. I've taken an exploratory analysis approach, but I can also get the information by running this SQL Property Graph query. This query shows me the ticket details, product names, suppliers, and the number of issues all in one result. And that's how easy it is to query a graph in the notebook menu.
So now let's take a look at what's happening under the hood. Ramu showed you creating a graph from a set of tables. And here are the set of tables she was using. There is a category table that contains all the categories of the different products you have in the database. The product table that contains information about the products and which category it belongs to. And then the components table, and that's all the components that make up the products. And then the suppliers that provide the different components. And then you have a table, customer tickets, which are customer complaints about specific products. And then you can see that the category table has a kind of a self-link to itself because some categories can be part of other categories. So when Ramu created the graph, what happened was each table mapped to a vertex type. A vertex is what you see as a dot here on this slide. And then the relationships between the tables that could be defined either by foreign key relationships or just connections between IDs become the edges that connect these vertices. So when you look at your data as a graph, it's the same data, but instead of looking at it as rows and columns, you're looking at it as a graph. When you look at this data as a graph, you're able to more easily navigate the relationships because the relationships in data have been made explicit. So Ramu showed you how easy it is to create a graph from these tables. And what really happens then is we create something like a view on these tables. We create a bunch of metadata tables that capture information about how data in the tables are linked to each other. And then the graph itself is like a view on these tables. What that means is there's no data copy, data is not moved. You're just creating a graph object on top of these tables. So you don't have to worry about synchronizing the data. You don't have to worry about updating the data. All data that is inserted, updated, and deleted in the tables that you're creating the graph from, all those changes are automatically available in the graph. So Oracle Database 23 AI has the ability to create a graph using SQL. And because you're building on mature features in the database, all the database features such as the ability to do fast concurrent updates, like you can have thousands of users running tens of thousands of queries, are all possible. Security and all of that is available for graphs. So this makes the graph data type in Oracle very well suited for OLTP workloads and also data warehousing workloads. So let's see what would happen if we didn't have this new syntax in Oracle Database 23 AI. So let's say you wanted to answer the question, which are the suppliers that this customer ticket eventually refers to? So customer is filing a ticket against a product. The product has many components. The components are supplied by suppliers. So if we want to see whether a particular supplier is just shipping inferior products, you want to connect the customer tickets to the suppliers. So without this new syntax for graphs and the ability to work with graphs, you would have what we have on the left. You would do a join and all of these tables. But now with the ability to create a graph, you can encapsulate all the tables and all the connections between them in this one object. Here we call it autograph. And then you have the simple syntax to navigate from the customer ticket information to the supplier information. So it makes it really easy to answer these complex queries easily. And then there are other patterns that graphs can help you find in your data, which is really hard to do without this new syntax, or in some cases impossible to do. For example, here in the first query, we're looking to see which are the categories that are highly connected in the graph. That is, which are the categories that have a large number of products, which in turn have a large number of components. We're looking to count all the connections that come from the different categories you have in your database. and then order them by the number of connections. So that's a simple query that you can see highlighted visually as well as a graph. And then you have the second example here. I'm running what is called a graph algorithm that you might remember from your data structures course. And here I'm running PageRank, which is a measure of how connected a particular vertex is in the graph. So when I run the PageRank algorithm on the graph, I can answer questions like, which are the frequently used products, or which are the frequently used components in products? And those are highlighted in the graph visual as well. So graphs really help you write these queries more easily and do more powerful things with your data. And the best part is, graph can be used with all the other features in Oracle's Converse database. You can write graph queries that work with spatial, with JSON, with vector, and of course with relational data. Oracle Database 23 AI natively supports all these different data types. So when you want to use graph queries with all these other data types, that can all be done in one SQL query, for instance. Now back to Ramu.
We've spoken about how graphs can help tackle complex problems. Now it's your turn. Dive into the hands-on lab and explore how graphs can tackle other challenges, such as fraud detection in the financial industry using graph algorithms. If you have any questions, do not hesitate to contact us. Thank you.